Live from the Washington, D.C. area, it's the Inside Scoop, Emerald Planet. All the ecology news that our viewers want to know. Now, here's your host, Executive Director of the Emerald Planet, Dr. Sam Lee Hancock.
Hello and welcome to the Emerald Planet as we come to you from Washington, D.C. in the United States as we look around the globe in 144 different nations, looking for those 1,000 best practices, the technology, services, and products that make a difference as we move through the 21st century. And of course, the real issue of the 21st century is not only energy, but also water. And that's going to be critical as the planet adds another 2 billion people by 2050 and maybe 12 to 13 billion by the end of the century. And I have a gentleman sitting right beside me who's looking at older cities and also the legacy systems, because they say there's over 2 trillion gallons of water is wasted on a year-to-year basis. And Tim, that's a lot of water. But this is Joseph Timothy, goes by Tim Nippitz. He's the president of what's called Re-Pipe 4710, and he's going to tell us what this 4710 is all about from Lancaster, Pennsylvania. And welcome.
Thank you.
Glad to have you back with us. Describe a little bit about this Re-Pipe 4710, what the 4710 is all about, but also what is the vision and the mission as you're looking at legacy water systems?
PE 4710 is the designation for a high-density polyethylene. It is a very robust material. It's new within, say, the last 10 to 15 years. And it gives enough substance to be used in a water main. The older high-density polyethylene was called a PE 3408, and it wasn't as robust, so it wasn't considered a good solution for water mains.
Yeah, let's stop for just a minute because we do want to put up a video so people can actually see this. So we're going to have about a 2-minute video, and then we're going to come right back in, Tim, to talk about the various technologies and the process.
Since we've used water mains in this country, we've used various materials. Cast iron mains installed in the 1800s to the 1920s have a useful life of approximately 120 years. Pipes laid in the 1920s to the World War II era have an average life of 100 years. And post-World War II pipes will last on average 75 years. As a result, we're approaching what is called the triple witching hour of the convergence when all of these pipes are wearing out at the same time.
When a water main fails, you can either dig it out or you can leave it in the ground. With Re-Pipe, we allow a folded pipe to go in the failing water main and to be expanded to become a structural pipe inside the failing water main. This structural pipe becomes the new pipe for the next 100 years.
Re-Pipe 4710 is a method of replacing water mains without digging up the entire street.
You can think of the Re-Pipe 4710 solution as taking a drinking straw, folding it, and inserting it in another drinking straw. It's that simple. Re-Pipe 4710's solution stands alone, delivering a structural pipe without requiring unnecessary excavation. This allows us to provide a better solution at lower cost to deliver water for the 21st century.
The AWWA estimates that $540 billion will be required to replace underground infrastructure over the next 25 years.
Our folded pipe solution is less cost, less effort, faster, and safer than alternatives in the market. This gives us a great market position to help America's water operators.
Even though Re-Pipe 4710 is a new product, it meets all of the safety standards applicable for water mains and can be used immediately.
There's nothing more precious than the water that comes to our taps and faucets. Re-Pipe 4710 looks to play an important role in rehabilitating the nation's drinking water infrastructure.
Tim, you're talking about the triple witching hour. What is the triple witching hour? And why is that applicable to the situation, again, with these legacy systems and these older cities across the United States?
Well, since we put cast iron mains in the ground, they have various lifespans. Mm-hmm. All three of the materials, the older material, which has a longer useful life than the newer materials, are all due to be replaced at approximately the same time. This is going to place a huge burden on water systems. The financial cost for just replacing is $540 billion, and an additional $460 billion is going to be needed to install new mains for shifting populations.
I know when they talk about that with the American Water Works Association, over $1 trillion
Yes.
with a T, and that's a lot of money. It's hard to think about. But the classification system, this is a very strongly regulated industry, and you have a class 4 as far as this in situ material that goes in to repair and to refurbish, even sometimes to protect the existing water lines. What is the class 4, and how is that applicable to the repipe?
We actually, it's a pipeline replacement product. It starts at one end and moves to the far end. So everything in between is brand new. You have high-density polyethylene for the pipe, and we'll use high-density polyethylene for all of the fittings.
Yeah, looking at these fittings, I know this is something that is very important. And what kind of material do you use there? And then is there a differential between the timeline for the fittings themselves versus the pipe? How does that actually work in the engineering of these systems?
Well, if you think of the two major causes of pipe failure are external corrosion, where the pipe is actually being eaten from the outside, and the other one is shifting soils. So if you have external corrosion caused by acidic soils, then everything that's metal will start to eat away. We replace everything with plastic. Jonathan Waldman wrote a book called Rust, and he says metals are mortal, and that's true.
Now, looking at this is all about the lead service lines, and of course the news media is replete with various of these cities, because the lead really was either mandated or was a product preferred by engineering, water engineers and civil engineers when they were building these cities. And now, of course, with the leaching and the various chemicals, that's no longer acceptable whatsoever. So cities are spending a tremendous amount of money to replace those. So how does this lead service, how do you actually get in there and take care of that, and where you're not having to pull up everything?
Well, in where there are lead service lines, our product is designed to go into the distribution main itself. But if you're replacing the main or the service lines, you should be replacing the main at the same time. So that's what we advocate, replacing the main and the service lines. And even in cities that don't have lead service lines, there are a lot of failing. If you have external corrosion on your main, you have external corrosion on galvanized or copper service lines. So basically what you're facing is a replacement of everything.
Yeah, you're looking at it, and this numbers by the U.S. EPA, United States Environmental Protection Agency, said there's almost 250,000 of these water main breaks, in 1 year. In 1 year, not over a decade. What does that cost to the cities, but also to the citizens, as far as all this water just being leached out in the ground?
Well, it's very expensive. Water main breaks it's not a controlled situation, so it doesn't matter what time of the day or night, or whether it's in the winter or summer, you have to go out and fix them, and that becomes very expensive. It also disrupts traffic. There's a lot of time lost for people who commute, because streets are closed, because the water mains are being repaired. It also detracts from the operating and maintenance budget of a municipality, because they're spending more on operations and maintenance than they are in replacement. So it's not, by replacing the mains, you will reduce your operating and maintenance budgets. So as one goes up, the other one will go down.
Yeah, and the whole thing about it is that, with the nature of, having, in essence, a grid type system, this is in water, not just electricity, but everyone is dependent on, these consolidated, or most people are dependent on these consolidated facilities. So it's a real impediment to the people, real impediment to their lives, when one of these mains go, because we've had some of that in the Washington, D.C. area. Sometimes the roads are closed for a few days, it may be for some weeks or even a month. And so it really is a detriment to everything, commerce, people, disrupting lives, livelihoods, and all that. But going on this, I'm going to look at this high-density polyurethane, these sheets that go in to protect these lines. Is that something that we should be using, and why is that being used to protect these existing water lines?
Well, what it is this is a movement by DIPRA, which is the Ductile Iron Pipe Research Association. And the nature of ductile iron, the manufacturing process brings up a thin wall. And the corrosive soils are eating away at the thin pipe. So to prevent that, they're wrapping this ductile iron, it's called bagging. They wrap it and they put duct tape around it. And
that's going into the ground.
That's to protect the pipe. That brings the cost of replacing on a dig and replace basis to somewhere around $150 to $200 a linear foot.
That's incredible.
Yeah, it's very expensive. So everybody is looking for less expensive alternatives, and that's what we're all about.
Now, looking at this, though, this polyurethane called high density, is this something that's actually safe for wrapping these pipes, particularly if the walls continue to decline, and also you're getting pinholes and other things where it allows extraneous water to get into the distribution system?
Well, water doesn't usually get into the distribution system unless the main fails, and there's a high hydrostatic pressure that will allow the water to come in. Most of the time under pressure, it's water leaks from the pipe, not intrudes.
Right, yeah. Well, still there's contamination in that whole thing. We are absolutely running out of time, so tell us a little bit about where you see your company being in the next 5, 10, 15 years, and we got about 20 seconds to do all that.
Well, our timing is spot on. The need is there, and we're there to fulfill it. So we expect big things in the next 5 to 25 years.
That's absolutely fantastic. Well, thank you for being with us. This is Tim Nippitz, President of Repipe 4710, talking about the distribution systems as we look around the globe to create the Emerald Planet.
I helped turn my child's public school into a whole new kind of school. One with a curriculum that really motivates kids. One that has extended hours, 6 days a week, year-round. With loads of academic, cultural, and recreational activities. One that has support services like medical and dental right there. A school where parents' involvement is encouraged, where teachers have more time to teach, and students are excited about learning. There's just one problem. My child doesn't ever want to come home. You can help turn your school into a community school for excellence. Find out how. Call 1-877-LOVE-TO-LEARN.
It's coming. Right to your neighborhood. And when it does, you may be surprised. It's your Social Security statement of your benefits, and it's going to help you plan your financial future. Your benefit statement will tell you how much Social Security you're eligible to receive and when you'll get it. Then you'll know how much you need to save for retirement, because that's coming too. The future is in your hands. Choose to save.
The toxic fumes from this meth lab are seeping into Jamie's sinus cavity. Ammonia vapors invade her throat. Toxic gases fill her lungs. Jamie's body is deteriorating. And she doesn't even know it.
Jamie, dinner.
So, who has the drug problem now? Find out how meth affects you at drugfree.org/.
We're back to the Inside Scoop Emerald Planet. Here again, your host, Dr. Sam.
Hello and welcome to the Emerald Planet as we look around the globe for those 1,000 best practices, technologies, services, and products, and of course the leadership that's making all this happen as we move towards 2050. And by 2050, it's estimated we'll be adding about 2 billion new people to the planet. So we'll have some 9 billion people that we need to provide water and all the other basic infrastructure to not only survive, but hopefully thrive. And we have two gentlemen in the same organization, Repipe 4710. Dana Hoffer is the Executive Vice President. He's going to be coming in by Skype. And sitting right beside me is Tim Nippets, who is the President of Repipe 4710. So welcome, Tim.
Thank you.
Glad to have you here. Dana, welcome to the Emerald Planet TV.
Thank you.
Glad to have you with us. Tell us a little bit about your background. I know that in your biography you have an extensive background in Fortune 500 companies and all that. Very impressive. And then all of a sudden you go out and looking at water, lots of mud, and many other things as far as trying to help older cities to address these legacy water systems. So why the Repipe 4710 and a little bit about the origin of the company?
Sure. Well, Sam, I'm an engineer by training, and I went to IBM and I helped part of the world get computerized. And then I went to Accenture and I helped bring the part of the digital. And now we're looking at the needs for infrastructure in this country. And what we see here is something dramatic. Our country needs to rebuild water networks, and that's attractive to me.
Well, looking at this repiping, if I can use that, it's estimated we're going to need about $1 trillion over the next 25 years to address these legacy systems throughout these older cities. And so that's a huge amount of money. So how with the Repipe 4710 can you actually try to save money, decrease the amount of disruption and everything that centers around going in and working on these legacy systems?
Well, the key is, Sam, that we need to do as little work to get to the mains as possible. And what that means is to use trenchless or less trench methods. We don't need to dig up the entire street to rehabilitate a main, and Repipe's 4710 solution is a solution that brings that forward. And we can, by our estimates, save the country 25 to 30% of that trillion, which means there's $250 billion of savings on the table.
I tell you, that's huge, and particularly when you're looking at all these cities are having to go out and try to find these monies to do that, and in many of these cities literally are bankrupt. So how do they find financing to take care of a problem like this, which could be tens of millions or hundreds of millions depending on the size and complexity of the system itself?
Well, Sam, for a long time, Americans have felt that water was correctly priced, and when their water bills came in, they felt they were paying the right price for the water. But what we've seen as a country happen in Flint has readjusted what the American perception is of the value of fresh, safe, clean drinking water coming to the taps in their homes. So what we're seeing across the country is citizens much more concerned and willing to pay more. And those rate increases are likely to be what allows us to refinance our water infrastructure and make sure that for our children and our grandchildren that we have the clean drinking water that we've enjoyed in our generations.
Yeah, on this particular slide, if we can bring this back up, this is something that really shows what can happen. I mean, this is one of roughly 250,000 of these that's going on around the United States. And then if you look around the globe, I mean, it's hundreds of billions of gallons of water is being wasted everywhere. Tim, why don't you ask the next question, if you would, please?
All right, Dana, we'd like to know about the replacement of the mains and how we reestablish it once the Repipe 4710 is installed inside the main.
Well, one of the big benefits of Repipe 4710 is that when we replace a main and we come to a fitting, we connect to a brand new plastic fitting. A T or a 45 or a service line connection is a brand new plastic fitting. And we do not rely upon any aspect of the old pipe network, because simply, if we're going to put in a pipe network for 100 years, we want to go new 100% of the way. And we still offer those savings that I mentioned of 25 to 30% to the municipality, to the community, even though we're delivering a completely new, fully plastic, ready-to-go pipe network for the 21st century.
Now, looking at this, as far as the repipe aspects of that, looking at this image that we have here, tell us a little bit about what is happening. It seems to be intuitive, but there's probably some things we may be missing. So how does this actually work?
Sure. On the right-hand side, we've dug an entry pit, and on the left-hand side, we've dug an exit pit. You can see at the bottom of the slide the old water main, and that water main has been cleaned out. Over decades, that main has filled up with rust, and now we've cleaned it out. And then the next step is to bring in the repipe. So we, from the right-hand side and the upper right-hand side, you can see the coil of repipe being inserted down the entry pipe into the old water main, and it's being pulled through to the exit pit using a winch. When that pipe is laid in, it will be expanded into the round and then attached with fittings. It'll then be pressure tested and put into service.
Well, this is, it seems complex, but actually it sounds quite simple. So how did you come up with this idea to be able to do this?
Well, I'm going to turn it over to Tim to talk about that, because Tim is our inventor and founder of Repipe 4710.
And we have him in the house. Tim?
Well, it actually started off rather innocently enough. That I was working on a project that was using something called cement mortar lining, and I watched what was happening. They were cleaning the lines so to improve water quality, and also the second purpose of water main is to for fire prevention by having adequate flow to hydrants. So I'm looking at this operation, I'm saying to myself, there's nothing structural here, so why not use a deformed pipe, pull it in and re-round it and add new fittings to it, and you'll have a brand new pipe rather than an old pipe with cement in the inside.
Let's bring up this slide so we can see this. Tell us, Tim, what we're seeing here. This is really kind of start to finish as far as the Repipe 4710.
Right. This is all this represents is the pipe being inserted in a deformed state. And it goes.
And this is the old water main itself?
Well, the red
pipe
circle you see on the outside is actually the old pipe. This happens to be a sewer line, but
correct.
It's the same. A pipe is a pipe. So the main goes. The pipe goes in. The high density polyethylene goes in. It's re-rounded, and you're seeing it being re-rounded in phases. And then in the end, it's a new pipe. Inside the existing pipe.
Now, how do you re-round this? What's the process for doing that?
It's using steam and air pressure.
Mm-hmm. Okay.
It's a fairly simple and well-known process.
So this is what we would see if we're going into the factory where they're actually making this repipe itself, and then that's shipped
That's
to
correct.
site, looking at it just like that.
It's a deformed pipe, yes.
Okay. Dana, coming back to you, we're talking about these connections, and we see all the various types here. Tell us a little bit about these, what they're made out of, and what's the different configuration for as far as being sure that long-term that you're locking the water into the system and not losing it to leakage or any kind of breakage over time.
Yeah. Well, the good news is that these fittings are not made out of metal, because metal corrodes and rusts away over time. The good news is that these are made out of high-density polyethylene, which many institutes consider to be the safest, form of plastic for the conduit of water. As you can see, there are T's and 45s and 90s here. And these are publicly available. These fittings are widely available in the market, which means that there's not an exorbitant price tag associated with these fittings. And as you can see, there's a variety of them, so that whatever a water company is faced with, whether it's connecting two distribution mains together to go to a side street, or if it needs to go around a corner, these are right here and readily available. Our plastic HDPE 4710 pipe that we just saw in its deformed condition, once it's rerounded, will connect directly to these fittings, and they will be electrically fused or welded together. And that's going to give us a connection that's actually stronger than the pipe itself, because once welded, the weld is stronger than the pipe itself. So we have a great deal of confidence that water operators can go with a brand new re-rounded pipe and off-the-shelf commercial fittings and be comfortable that that's a 50, 75, 100-year solution.
Now, this high-density polyethylene, this HDPE, there's something that's being used as far as trying to protect the old pipes. In your opinion, do you think that's really a safe use of that particular product? And if yes, why? If no, why not?
Well, yes, we think it's extraordinarily safe. It's a completely inert plastic compound, and it's rated by the National Sanitary Foundation as surpassing the standard 61. You can Google this on the internet and find that HDPE is the recommended container for potable drinking water. So if you're storing water for an emergency, you would store it in a HDPE container for maximum comfort and confidence.
Tim, why don't you add, we have to be quick. We have two more questions, Dana, and we need to fit them in about a minute and a half.
Dana, can you tell us something about the useful life of high-density polyethylene, PE 4710?
Well, Tim, the Plastic Pipe Institute believes that HDPE has a service life exceeding 100 years, which, as we know from our pipes in the ground, is superior to ductile and cast iron.
Well, what do you see for the next 5, 10, 15 years, Dana, as far as the growth of your company?
Well, I think we're going to be pretty busy, Sam. I think we have a solution that can really help water operators, communities, the country. I think it's a more attractive solution, both from its properties and its costs. So we're going to be busy. Thank you, Sam.
Well, thank you for being with us, Dana Hoffer, and right beside me is Tim Nippitz, and this is for the Re-Pipe 4710. Thank you for being with us as we create the Emerald Planet.
Saving for retirement might be easy for some folk, but for others, it might take a little more work. And for those who haven't started, there are still things you can do to catch up.
Oh, that is good news.
Like getting out from underneath past debt. And don't get wrapped up with high-interest credit cards.
Get you some eyes.
Be diversified with your investments. Don't put all your eggs in one basket. Your financial goals are not out of reach. The choice is clear. For a happy ending, choose to save.
Everyone with alcohol and drug addiction is in the same boat. With treatment, you can find solid ground. For drug and alcohol information and treatment referral for you or someone you know, call 1-800-662-HELP.
Dude, are you sure you want this tattoo? Because just do it.
Some mistakes in life are permanent. Like hearing loss. To learn how to protect your hearing, visit asha.org.
You've probably heard about heart disease, but did you know that it's the #1 killer of women nationwide? Heart disease claims more lives each year than breast cancer, lung cancer, or strokes combined. But there are steps you can take to protect yourself against it. For more information on how you can prevent heart disease, contact your local American Heart Association or visit their website at www.americanheart.org.
We're back to the Inside Scoop Emerald Planet. Here again, your host, Dr. Sam.
Welcome to the Emerald Planet as we come to you on a week-to-week basis as we look around the globe looking for the critical technologies, but at the same time the critical issues and also the basic infrastructure as needed to address a population on this planet by 2050, which is estimated to be about 9 billion people. And of course, the essence of life is water, and so water is a major consideration. And so now they're saying that water is the new oil, and it's something that must be addressed before 2 billion new people join us on the planet. And we have millions of linear foot of old pipe that's in the ground that's been put in legacy systems, not only in the United States, but major cities all over the planet. So we're going to be really focused on the United States, but you can extrapolate this to the rest of the world. And we have a gentleman that's coming on. He's part of an international company. He's going to tell us about that. His first name is Matthew, goes by Matt Wassam. He's the Vice President, Western USA, of what's called Aqua-Pipe. And they're out in Colorado, and sitting right beside me is our good friend and actually an all-around good guy. And this is Dr. Jose Colucci Rios. He's a professor retired out of the University of Puerto Rico. And Matt's coming in to us by Skype, and thank you for being here with us, Jose. Matt, welcome to the Emerald Planet TV.
Thank you so much. Thanks for having us.
I'm glad to have you here. Tell us a little bit about Aqua-Pipe itself, and then also the parent company of this, and you really are an international company, so tell us a little bit about that, because you have a worldwide footprint, which is quite impressive.
Thank you very much. Aqua-Pipe was invented a little over 12 years ago by Sanexen Environmental out of Montreal, Canada, with a very clear mission. The mission is to solve the global buried infrastructure, drinking water infrastructure crisis that we're talking about today. Aqua-Pipe uses a combination of plastic composite materials, not unlike those that are used in aerospace, combined with robotic equipment to rebuild buried drinking water infrastructure from the inside of the pipe without all of the digging.
Yeah, the whole thing about using the Aqua-Pipe and trying to pull up, and I guess they call it a trench methodology of putting it in when you have green space and you're putting in these systems. You put it down, of course, below the frost line, hopefully in these various areas. But all these legacy systems are getting to the end of their useful life. So why would you develop something like an Aqua-Pipe? And how is that different than this trench, dig and cut, I guess, as far as putting in new systems within these various older cities?
Sure. I think one of the most obvious differences is that we are simply creating small excavations at each of the valves and hydrant tees, and then we're again using these innovative technologies to rebuild the infrastructure between these 2 points with a very, very small fraction of the digging. One of our biggest drivers is cost, of course. Municipalities are cost sensitive. And so we typically find, or municipalities typically find, that using Aqua-Pipe to solve these problems, they're able to do more with less money. So a savings of 30 to 40% allows municipalities to simply rebuild more pipe using this technology.
And also, too, I would assume, Matt, they're having to borrow less money or go to the taxpayers and increase the fees to the ratepayers so that actually they can be doing more with less at the same time.
That's absolutely the case. But more importantly, I think from a ratepayer's perspective is the disruption. The reality is that there's never a time during an Aqua-Pipe project that a business or homeowner is actually out of water, because we provide a temporary water system on the surface to each home and business. So the disruption to businesses and homeowners is very, very little. In fact, one of the first comments folks make when they see one of our projects is that they quickly notice that we have a few pits 400 to 1,000 feet apart, 400 to 1,000 feet apart. And that's being replaced between those pits is, there's almost no disruption. But we can also rebuild around a mile of pipe every single month. And so the other major benefit to using Aqua-Pipe is the speed at which we build drinking water systems. We're very, very quick.
Now, looking at this diagram here, tell us a little bit, Matt, what we're looking at, because normally this is something that most people would never see, wouldn't even know it's there. They just want to be sure that their water is coming out of their tap when they turn it on. But what are we looking at here, and where is your product as we're looking at this diagram?
Sure. So what we're looking at here is a cross-section of the Aqua-Pipe materials. And in order to produce a Class 4 structural rehab solution, this material has to be very, very tough. It has to be able to withstand all of the inner forces, which is water pressure, as well as those forces that are exerted upon this material from the outside, whether that be traffic loading from above or soil loading on this pipe. And so we have to produce a very strong pipe material. We do that by having a double jacketed hose liner, as you can see in this cross section, that is impregnated with a proprietary resin system. And the two combine to produce a very, very rigid, strong pipe that doesn't have any dependency whatsoever on the old hose pipe. After all, most of what we're working on are very old pipe systems. And so we have to produce a fully structural pipe in order to provide municipal drinking systems with a 50-year design life pipeline.
So what you're doing then, Matt, you're just using the old system really as a form, and then you inject or put this material through there, and then that becomes a structural property itself.
That's a great way of saying it. Yes, we produce a small access pit at valves and hydrants. So virtually every block will have a small 6x8 access pit. We put this material inside of the pipe. We then enter the pipe with robotic equipment and temporary plug each of the service connections so that we don't allow any resin to migrate into the service connections. And we pull this material in place. We cure it using hot water. And when we're finished, we have virtually manufactured a new plastic pipe underground without all of the digging.
Wow. That's amazing. Jose, you have the next question.
Sure. Yes, good evening, Matt. Could you elaborate on how the in situ Aqua-Pipe system compared to the open ditch when you're replacing the older, worn-out legacy system, especially when you're considering the pricing, the installation time, service disruption, and other factors that you may want to discuss?
Sure. Excellent question. We have this crisis at hand. Nobody is debating that. All the municipalities around the country appreciate the fact that we have a real crisis with buried drinking water. In fact, today, trillions and trillions of gallons are lost every single day through leaks in existing infrastructure. And so that's really the driver for our technology. Municipalities are recognizing that the conventional means of digging and laying new pipes in a trench are not going to reach their goals. If you take a look at asbestos concrete pipe, which is a fairly common pipe material specifically in California, there are literally tens of thousands of miles of AC pipe just in the state of California. So conventional replacement is simply not going to get the job done in time. And so that's why we're really focused on green technology that's fast, less expensive, with a small fraction of the disruption. And those are probably the biggest difference between conventional replacement and lining these pipes with structural Aqua-Pipe.
Looking at the Aqua-Pipe system that you have, Matt, tell us what the life expectancy of what it is that you're actually putting in the ground, and maybe compare that with some of the legacy systems that you're actually helping to refurbish or improve in any way.
Sure. Our material is very simply, Aqua-Pipe has a 50-year design life. But more importantly than the design life is the fact that it's an entirely jointless material from pit to pit. And so today, for example, in any given street where you have ductile iron pipe or cast iron pipe or even some AC pipe materials, the problem really mostly exists at the joints where they have leaking taking place at these old joints. And our material is completely jointless because we're manufacturing it on site inside of the old pipe. We have the luxury of avoiding joints entirely. And so a municipal engineer can design this project where we have literally 500 to 1,000 foot runs of pipe that don't even have one joint in them. And so although we have a 50-year design life, which is on par with all of the other materials, more importantly is the fact that we don't have any joints in the pipeline.
Now, looking at some of these images that we have here, I know you're talking about really what you have is a continuous process manufacturing facility on site. Right. So tell us a little bit about this equipment. We have an image of it in the upper left as we're looking at the screen. And then I assume all of this is going on at the end of the street, and then people are driving over top of it, and work is just continuing right along along with the water, if I understood what you said earlier.
Yes. What you're looking at right there is actually the robotic truck. So the operator of the robotic equipment works from inside of that vehicle. We do have some traffic disruptions from time to time, but they're a very small fraction, as you can imagine, as compared to an 6-foot wide trench or 4-foot wide trench that's running the entire length of this street. And so during construction, we have, again, 6 by 8 pits or so every 500 to 1,000 feet. Those pits are located at where existing valves and hydrant tees are. And so what you're seeing here is simply an example of a residential project where we are lining from those points. What you don't see here are some of the other equipment. We have a boiler trailer, which is a piece of equipment that is used to heat the water. We also have a manufacturing trailer, which is a typical semi-van trailer that's on site. And those are virtually all of the pieces of equipment that will be on a traditional Aqua-Pipe project.
Yeah, it's just amazing where you see all this activity of a modern urban setting going on right around your facilities, and they're just working away inside these trailers. We're running out of time. What do you see yourselves being in the next 5 to 15 years? You got to be quick.
I think more and more communities are finding this to be a solution to their infrastructure problems, and so we're growing as fast as we can.
Matt and Wassam, thank you very much for being with us, and Jose, thank you for being back as we look around the globe to create the Emerald Planet.
Education for children and adults.
Educación para niños y adultos.
Immigration, naturalization, and medical referrals.
Ayuda para los procesos de inmigración y naturalización y orientación sobre médicos.
Are a small part of what we do.
Son solo una pequeña parte de lo que hacemos.
For help, information, or to volunteer.
Para ayuda, información o para ofrecerse como voluntario.
Contact the Hispanic Committee of Virginia.
Comuníquese con el Comité Hispano de Virginia.
Helping everyone participate more fully in American society.
Ayudando a todos a participar plenamente en la sociedad norteamericana.
Where's yours?
Would you notice if you were missing half your kidney function? According to the National Kidney Foundation, 20 million people have chronic kidney disease, and 20 million more may be at risk and not even know it. Anyone with high blood pressure, diabetes, or family history of chronic kidney disease is at risk. Early diagnosis is vitally important. To get the whole story, talk to your doctor and visit the National Kidney Foundation at kidney.org or call for a free brochure. Because when it comes to chronic kidney disease, you might not know the half.
we're back to the Inside Scoop Emerald Planet. Here again, your host, Dr. Sam.
Hello, I'm Dr. Sam Hancock, the President and Executive Director of Emerald Planet and also of the Emerald Planet TV. We come to you on a week-to-week basis, bringing 4 shows a week, looking at the best of the best, the advanced technologies and services, products, and of course the people that are making a difference as we move through the 21st century. And we're going to a planet with 9 billion people by 2050, and possibly another 12 to 13 billion will be on this planet by the end of the century. So water, of course, is the essence of life. This is something that Jose, sitting right beside me, knows all about. And so we're talking about how we're going to be able to protect what we're doing, but also to add to the infrastructure. We have a gentleman who's very much involved in a very unique and progressive system. This is Matthew, goes by Matt Wassam. He's the Vice President, Western USA for Aqua-Pipe, located in Littleton, Colorado. And our good friend and buddy, Dr. Jose Colucci Rios, a chemical engineer, so he's at the right place at the right time on this. Professor retired out of the University of Puerto Rico. And Matt's coming in by Skype. Jose is here with me in the studio. And Matt, welcome to Emerald Planet TV.
Thank you very much for having us.
I tell you, it sounds like you have a tiger by the tail. $1 trillion, they're estimating, this is the American Water Works Association, over the next 25 years, that they're saying must be spent on these legacy drinking water systems all over the United States, and of course then trillions more around the world. And then you have this unique product, this Aqua-Pipe. Tell us a little bit about that, and how does that fit into this narrative that we hear about almost day to day as far as drinking water, the contamination, or the lack thereof, or what have you, and the demands that we're going to be seeing as we move through the 21st century?
That's a great question, and no doubt we all hear about water main breaks. We hear about some 2 billion gallons of water that are lost every single day through leaky infrastructure that has exceeded its design life. It's a major crisis globally, and we have developed Aqua-Pipe. Sanexen Environmental has developed Aqua-Pipe specifically to solve that problem globally.
Now, looking at the Aqua-Pipe, I know this is something that we've been talking about before, but one of the things as you go in, you have these water main breaks, and people having to take alternative routes to their work. They're closing down schools or municipal buildings. People are not able to provide water for themselves, and of course, you have Flint, Michigan, you have Charleston, West Virginia, Cleveland, Ohio. You have many of these older cities are having these problems. How disruptive is it with this Aqua-Pipe when you're coming in and actually replacing or refurbishing and renovating all this pipe that's in the ground, which is literally over 1 million miles, as I understand it?
Yeah, it's amazing how, the volume of infrastructure that we're talking about is unbelievable. In terms of disruption, it's a very, very small fraction of the disruption. People that come to one of our Aqua-Pipe projects notice one of 2 things almost immediately. One of them is there's not a lot from the surface going on. It's a very quiet job site with 500 to 1,000 feet between small access pits. It's almost hard to tell that the water main's being replaced. The other component that we have on every single one of our water projects is that we provide a temporary network of drinking water pipelines on the surface to each business and home, and so nobody's ever out of water. And so we replace 5,000 to 7,000 feet of drinking water mains a month, with really few people even know that's what we're doing.
Now, looking at the equipment here, this is something that you and I are talking about before, and I was hoping to have a composite image, and hopefully I'm doing justice to you, Matt. But tell us a little bit about this equipment And what is actually going on here, and how is that actually serving the ratepayers, the customers of this, but also whether it's a privately owned or publicly held water utility, how are you actually helping those utilities to do their job better, faster, at less cost?
Right. So we've developed a technology where we are bringing the manufacturing of the pipe materials to the job site. So instead of hauling joints of pipe to the project site, digging a long trench and laying those pipes in the trench, we're building those pipes right in place inside of the existing hose pipe. So because most of the pipes that we work with are 50 to 100 years old, we have no dependency whatsoever on the hose pipe. So we're putting a fully structural Class 4 replacement equivalent pipe inside of the old pipeline. And we're doing so by manufacturing it in place. The equipment that you see there is a combination of some hot water boiling systems that we use as part of our composites curing process. There's also a robotics operator's truck in one of the photos that I saw there. One of the trucks is a tractor trailer that is where most of the manufacturing takes place. And so it's a very small footprint. We have just a handful of pieces of equipment, and we rebuild a lot of pipe in a short amount of time.
Now, looking at the image to the left on the screen that we have here, and maybe also the one on the right, is this the surface water distribution system that you actually put in place that goes along in front of the installation of the new installations going on inside the old pipe?
I believe that is what we're seeing on the left. I apologize, I can't quite see it here, but temporary water service is normally laid right on the surface in the gutter. It is a slight inconvenience for homeowners and businesses during a week or two during construction, but they're very happy to have that slight inconvenience in exchange for not having an open trench in front of their home for several weeks. And so most folks are very happy with it.
Jose?
Yes,
question, sir.
Sure. Good evening, Matt. How do the water consumers know that the Aqua-Pipe is safe for handling the drinking water? And also, what are some of the requirements that the Environmental Protection Agency, or EPA, requires for your technologies and your processes?
That's a great question. Every element of municipal drinking water systems are approved by NSF International. Mm-hmm. And Aqua-Pipe is fully approved by NSF International to NSF 61 standard. So that is a comprehensive test that tests everything that goes into our systems for safety. So that's the answer to your first question. The second question, EPA regulations, I'd like to just comment on specifically on asbestos concrete pipe, for example. In the state of California, there's over 10,000 miles of asbestos concrete pipe in the ground. And California has a real crisis on their hands because most of that pipe is reaching the end of its design life. The EPA has really put into place some stringent standards for how to address this dangerous material. And they've arrived at a conclusion that perhaps the safest way of dealing with it is to leave it in place and line it with Aqua-Pipe, a fully structural replacement pipe. And that's really driving some business for us right now.
Yeah, looking at this image here, this is not something that you're actually purposely doing. This is a water main break, and it's shooting water about 25 to 30 feet into the air. So it looks like that actually you're addressing some very serious issues and of these legacy systems all over the United States. How do you take care of something like this where you have the dynamic where you're trying to keep the water on for people, but at the same time to cure something that's obviously quite dangerous?
Right. Well, most of our projects are driven by water main breaks, unfortunately. And so every municipality, they're doing a great job with what they have. And they keep very close track at the frequency of water main breaks within their system. And when those frequencies exceed a certain number per mile, for example, they will put those projects on a list of pipelines that need to be replaced. And increasingly, more of those communities are contacting Aqua-Pipe to have those pipes lined with this structural material rather than replaced. But indeed, pipe bursts and pipe breaks like this are really driving the need to replace a lot of the buried infrastructure.
Now, you were talking about there's, I guess, 2 billion gallons of water that's being wasted on a day-to-day basis. The U.S. EPA says there's over 240,000 breaks as far as water mains around the United States. And I've traveled in now 89 countries and abroad, and you're having these same issues. So if you have that much that breakage as far as these systems, how do you actually, how fast can the cities be able to improve these systems so that they can stop that? Because that's a tremendous loss of water, and that's actually the most precious resource we have on planet Earth.
Yeah, that's a great question. And you're right. We are behind the curve at the moment nationally in addressing this problem. And if you take the thousands of miles of pipe that major municipalities have, they literally need to replace hundreds of miles a year just to get up to pace with where they should be in terms of replacing water mains. And so the way that we propose that this is addressed is, of course, lining these projects instead of replacing, because of the fact that we can do so much more in less time with a carbon footprint reduction of almost 84% for less money. So it seems like a no-brainer. And one of the things that's encouraging to me is repeat clients. So we have municipalities that try a pilot project, a mile or two of pipe, and the fact that they're coming back and doing more and more business with us is an indication that they are also seeing that this is a real solution for those problems.
We're absolutely running out of time. How green is this whole process and the product itself? And we have to be quick because I want to ask you that question, where are you going to be in 5, 10, or 15 years? So
yeah,
always got to get that
in. When you mobilize this small footprint of equipment and you manufacture this right on site, we have a reduction in total greenhouse gas reduction of over 84%. Very green. We're going to be building a lot of pipe around the country in 5 or 10 years.
Well, thank you for being. This is Matt Wassam. He's the Vice President, Western USA, Aqua-Pipe. This is Dr. Jose Colucci Rios. I got to get it all in there. And thank you for being with us. Jose, thank you for being back. And thank you for being with us as we create the Emerald Planet.